We'll start with a quick setup. So if you do not have Python already installed, I suggest checking our tutorial. First of all, you'll need to install Python, like I said, if you do not have it already installed. After that, you'll have to verify the installation. And moving on, you'll need to install PyCharm, but for this tutorial, we'll also use Google Colab. So if you're not familiar, I'll show you in a few seconds. And you also have a quick tutorial of how to create a project in PyCharm. So yeah. I'll be moving on really quickly to our first lesson. So in programming, we have something really useful and handy, and they're called variables. In programming, a variable is used to store information that can be used later in your program. You can think of a variable as a label container in your computer's memory for a specific data. In Python, to create variables, we just have to specify the name of the variable and its value. You have a really short example. And of course, every variable can store different types of data. Some of them are integers, aka whole numbers, float, aka real numbers or decimal numbers, like such as 1.5 or 3.114. Strings, which are basically chunks of text. Boolean values, also called logical values. They're either true or false. Working with variables. Of course, we can use variables in expressions and also print values. I'll show you really quick an example. Let me delete this. Okay, so for example, I can declare a variable, and let's just say I have a name variable, and I'll set its value, to a string. A string is marked by these double quotes, and then we can just print it. By the way, this is Google Colab. It's our support for running Python programs and Jupyter notebooks. If you do not know what a Jupyter notebook is, they're basically Python files that allow us to execute Python code, but the difference between a .py file and IPNB file is that the code is divided in cells that can be run individually, such as these ones. Okay. We can also update a variable, a variable's data, just like here. Okay, now a handy trick about strings is that we can concatenate them. What does concatenation mean? So let's just say I have a variable name and a variable surname. And a third variable called full name. Oops. surname. And now if we'll print this, oh, wait. Oops. Oh, my bad. Okay. Yeah, so basically concatenation means that we can take 2 or more strings and basically merge them into a single string. I can also add a bit of space. Okay. And now if I run it again, by the way, to run a IPNB cell, you can just use Shift plus Enter, or just use the run button. Okay. Moving on, we have a more complex sort of type of data, and those are arrays or lists. Arrays basically contain multiple values. They're literally a list of values. So okay. In order to access data from a list, we can just use an index. Every single list has an index that points to a specific value from within that list. You can see in this example, we have numbers and names. Lists are declared using these brackets. Okay. And in order to print something from a list, we can just use the index operator and specify the index. In the case of lists, the index operator is a whole number starting from 0. Okay, let's see some code in action. Oh. Let's just say I have this list and list 1 equals to 1, 2, 3, 4. And in order to get the first element, I can just say print list 1, 0. And here we have our first element. Same goes for the other elements. For example, if I want to print the last element, I can just say list 1, 3. Okay. Oh. Now, another type of data are tuples. A tuple is similar to a list, but we say that it is immutable, which means that once we created that list, we cannot modify it anymore. Yeah, tuples are often used when we want to group data that should not be modified. It's really similar to a list. We can access its values or elements, similar to a basic array or a list, but we cannot modify it. So moving on to dictionaries, the difference between a dictionary and a list is that a dictionary stores values using key pair values, such as these ones. So in our case, user has 2 elements, one with the key name and its value Alice, and one with the age key and its value 22. The main difference is how we access elements in dictionaries. So in dictionaries, we can just specify the key that we've defined in here, and if we want to print the value of name, we can just say user name using double quotes. Okay. Dictionaries are useful when we want to label our data in order to be more explicit. And here you have a short exercise which you can use to practice. And yeah, also a few things about concatenation. Okay, let's move on to our next lesson, conditionals. Conditionals allow a program to make decisions based on a certain conditions. Yeah, they are really important because they allow our program to be more complex and do more meaningful stuff. The basic syntax is that so in our example, we have a variable age, and we can just use the if keyword. Here we specify our expression or condition. In our case, age needs to be more than 18, higher than 18. And if they are higher, if their age is higher than 18, then we'll just print the text, you are an adult. Okay. Moving on, we have Boolean expressions. So Boolean expressions return a Boolean value. So it means that it's either true or false. Here we have a few examples. So let's just say we have a variable x that has the value 10. And if we want to verify some expressions based on our variable, we can just print them directly. X is higher than 5, or if x is equal to 10, or if x is less than 3. Okay. Moving on, we have something, yeah, I can say that it's a handy feature. The else statement, or the else keyword. The else keyword allows our program to have a secondary case if our condition is not met. So let's just say that we are not yet over 18, and in this case we want to print that we are a minor. We can just specify the else case and the block of code that we want to run when when our age is less than 18. There's also a keyword called elif, and we can specify secondary conditions or multiple conditions. If our first condition isn't met, then we can verify something else, and in the end we can just say that if these are not met, we'll print this text. We also have something useful called the comparison operators, which you've already seen them in these expressions. So we have equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. we also have logical operators. So basically, logical operators allow us to combine multiple expressions into a single expression. Such as, a good example is the AND operator, which translates to if this and this are true, then we will run this code. The OR operator basically just says that if this or this is true, then we'll run the code. The key difference between the AND operator and the OR operator is that in the case of the AND operator, both have to be true. For the OR operator, we just need one of them to be true. And the NOT operator, or the negation operator, just says that whatever it is this, take the opposite of it. So if in this case, if age is not higher or equal than 18, so if the age is not higher or equal than 18, then it's less. So that's basically the negation of this expression. And here you have another example and a short exercise if you want to practice. Moving on to our next lesson, loops. So basically, loops allows us to repeat a certain block of code multiple times. So this way we won't have to rewrite that specific block of code. For example, if we want to run it, I don't know, 100 times, then we can just use a loop and run it for 100 times without writing, I don't know, 200 lines of code. The first example is the for loop. So the syntax of a for loop is that we just say for a variable, in this example we just use the range function, which basically iterates through values from 0 to our end value. And in this case we'll just print this value. And this is the output. The range function is pretty handy because we can loop through different intervals of numbers, such as these ones. If we just want to go from 0 to a number, we can say range of n plus 1. If we want to have a lower limit and an upper limit, then we can just specify those two. And in this case, where we have 3 parameters, we have the lower limit, the upper limit, and the step. In this case, it's just gonna print 0, 2, 4, 6, and 8. The while loop is another type of loop, and it basically is very similar to the for loop, but it only runs as long as a condition is true. Here you have an example where we have a variable count, and we basically say while this variable is less than 5, we'll print it and increment its value by 1. And we can do this by saying count equals to count plus 1. There's also infinite loops if you ever need to run a program until, I don't know, a specific time. You can just say while true, and this will run forever. But yeah, we usually want to avoid this. Here you have another exercise, and we can solve one really quick. So I'll take the first exercise. We're gonna write a program that prints numbers from 1 to 10. Okay. So I'm just gonna say I'll be using a for loop. So I'll just say for e in range 1, 11. And then I'm just gonna print I. And here we have all of the numbers from 1 to 10. If we want to specify the step, we can just say, I don't know, by default the step is 1, so it increments by 1. But I don't know, let's just say that we want to go from 3 to 3. And here we have the numbers 1, 4, 7, and 10. Okay. Moving on to functions. Functions are a pretty handy concept. So it basically allows us to write a code of block, and we can call it whenever we want to use it in our program. They also help us to avoid repeating code and to organize our program better. In order to define a function, we'll just use the def keyword, followed by the function name, and these 2 commas, breaks. So in this case, we have a function called greet, and all we want this function to do is to just print hello. To call a function, we'll just say its name and followed by this. I'll write a short example. So this I'll just write this function def greet, and I'll just print hello world. Now if I run this, nothing's gonna be printed, but if I say greet, we can see that it prints successfully the text hello world. We can also add parameters. So functions can basically take inputs, and yeah, they are called parameters. They allow us to pass data to a function and basically do stuff within our function with that specific data. So for example, in our greet function, we can add a parameter called name, and we can just print hello plus our name. I'll show you in a bit. Wait, no. Okay, let's update our function, and I'm gonna say name and surname. I'll modify the text. And now we can basically concatenate our variables. Plus space surname. And in order to pass data to a function, we'll just add values to our parameters. Okay. Each value is separated by a comma. And yeah, we have hello Andrei Lascu. Oh. Okay. In cases, there will be cases and or times when we won't know exactly how many parameters we'll need. So in this case, we can just use the args keyword, and it basically gives us a list with values. In our example, we have defined the add numbers function, and we have the args keyword, keyword as our parameter. Now, let's just say that we want to print the sum of our specified values, assuming they are integers or floats. For this, I'll just declare a total value initiated with the value 0, and then we can just iterate through the args list. So we can say for number in args, we can add to the total variable the number, and then we can just return the value using the return keyword. I'll use this example so you can see how it runs. Okay, and now we can specify a list as its parameter. And here we have the sum of our numbers. We can also specify names for our variables, and the difference is that they'll be stored as key value pairs, so basically a dictionary. Here we have an example, and here is the usage. Okay, when it comes to functions, we also have recursive functions, and basically recursive functions are functions that call themselves in their block of code. An example is the countdown function, where we have our base case and our main code. So the structure of a recursive function is that we have our base case, which has a predefined value, and then we have the other part of our code in the else statement. Okay, I'll just copy this so you can see how it works. Okay, now if I call countdown of 5, it should print the numbers from 5 to 1, and done. Recursive functions are quite useful, but we don't really use them. They're useful when we want to break a problem into smaller problems and solve them individually. Okay, and yeah, we can also return values, but you've seen that before. And here you have some exercises if you want to practice. Okay, now that's it with the theoretical part of our workshop. Here you have a small project that you can build. Yeah, so basically the project is to build a guess the number game. And you have these steps prepared, you'll just need to follow them. Okay, so how it works is that it generates a random number. It asks the user to guess the number, and then we can just tell the user if the number is too high or too low, depending on the number that the user wrote. And we'll just repeat this until the user guesses correctly. Now, I'm not gonna write the whole program. You have the explanation here, but I can show you how it works. Wait, I'm not sure if it's gonna work here, but we can try. Okay, so it works something like this. And if it's too low, then the program will tell us. And if it's, I don't know, 100, it's too high, and so on and so forth until it guesses our number. Okay. Oh. Additionally, you have some challenges that you can pick, and you can do one of them or all of them depending on how you want to practice, or if you want to practice more. I'll also send my programs for these challenges, but I recommend to try it yourself first, so you can practice your knowledge better in Python. And you also have a small cheat sheet. Yeah, so this was the workshop. Thank you for listening, and I hope you found it useful. And yeah, that's it from me. See you next time.